Welcome to another series of the King tutorials. In today's tutorial, we're looking at the second aspect of circle geometry. Now, under today's video, we're looking at secants and tangents. Okay, so what are secants? Secants are lines that cut a circle at two distinct points. Okay, that means when I draw my line through my circle and it cuts two distinct points, say point A and point B, this is a secant. Line MN here in this case is the first secant. Now this is also another distinct point A1, B1. That means for this distinct point A1, B1, this is my second secant. So and so on and so forth. These are secants. Drawing a line through a circle, okay, cutting two different points. Now for a tangent is a line that touches any point on the circumference of a circle. Okay, any point on the circumference of a circle. Now this point T here is a tangent in this case. Okay, this is the point on the circle which this line crosses, line N. Now, in this case, this is also a tangent AB. Now for tangent AB in this case, we have it to be to be directed from the center to the point AB. So that means this place is automatically will be 90 degrees. Why? Because you have a radius which intersects at point, which intersects at T on line tangent AB. And for this case, we have two tangents here, okay, which are tangent BP and tangent AP. Now from this case, we notice that this place is 90 degrees. Why? Because we have a radius and we have a tangent AB. Now the same thing applies here. For tangent AP, the angle of 90 degrees to this side, that's OAP. The same thing here for tangent BP, the angle that will be 90 degrees of and OBP. So this is how to represent it. Now one of the parts of this theorem is that given two tangents, the tangent will equidistance. Okay, that means the tangent will having equal length. So that means BP is equal to AP in this case. And since that is so, we have OP to bisect BPA. To bisect BPA. Now finally, we have intersecting chords. Okay. Now in this case, we have chord PQ to intersect AB at I. So I in this case representing where they intersect. So in this case, to solve questions like this is by saying AI or IA times IB equals PI times IQ. So we have that IA times IB equals IP times I Q. That's for this case. Now for this second case of intersecting chords, we have a line and a tangent. Okay, we have a line QI and tangent line QP and tangent TI, where these all intersect at I. Now for you to solve questions like this, where this is the tangent and this is the line, is by saying IP times IQ equals IT all squared. Okay, so that is how to solve questions in this case. Okay, so now this example says calculate the length marked X in the diagram below. Now for this for question 1, this question 1's diagram, I look for X. How will we find X? Very simple. From what we discussed earlier, we know that OA times OB is equals to OD times OC, which relatively implies that OA is 6 times OB is 4 equals to OD is 5 times X. So we have that 24 is equals to 5x. Therefore, X is equals to 24 over 5. Which now leaves our answer to Which now leaves our answer to 4.8 centimeter. Now, for number 2 question, this is the diagram. Okay, we're looking for X in this case. Now, it is similar to this one. Okay, it's just that in this case, it's going to be IN times IM. Okay, equals to IR times IS. So let's write that down. IN times IM is equals to IR times IS. Now IN here is 6 times IM is from this point to this point. That's 6 plus 10. Okay, equals IR is 8 times What is IS? IS is what from this point to this point. That's what 8 plus what plus x. That gives us what 6 times what 16 equals what 8 times what. That becomes what 64 plus what 8x. So 6 times 6, that's 36. 6 minus 3. 6 times 1, 6 plus 3 96 equals what 64 plus what 8x. So what do we have now? That becomes what? This comes here. That becomes 96 minus 64 equals what? 8x. Okay, so what do we have? That becomes 32 equals 8x. Where our x therefore is equals to what? 4. That's 32 divided by 8. For last question. Now this is where we have the line and what? A tangent ET. So in this case, what am I going to do? I'm going to say what? EF, isn't it? Times EG equals to what? ET squared, ET all squared. So what does that become? Number 3. That becomes what? EF times what? EG equals what? ET or what? All squared. Now what is EF? EF here in this case is what? 8 times what is EG? EG, the total is what? 20 as given to us. Equals what? ET is what? What are we looking for? X. That's what? X squared. That becomes what? 160 equals what? X squared. Where our x is equals to what? Square root of what? 160. Hence having our answer to what? 12.8 centimeter.